In today's session, we shall talk about balancing of redox equation. Rather, we shall talk about complete balancing of a redox equation. What does it mean when I say complete balancing of redox equation? It's so common that we balance a redox equation, but I am talking about a step further. When we go for complete balancing of those components which have not been taken into consideration in redox equation, right? So this is our today's topic. So before that, let us quickly summarize what is the half equation method. I hope all of you are acquainted, very well acquainted with half equation method. So let us summarize it quickly. So half equation method has certain well-defined steps. Number one is balance elements in equation other than oxygen and hydrogen. Number two, oxygen atoms are balanced by adding appropriate number of water molecules to the opposite side of the equation. Number three, balance the hydrogen atoms by adding hydrogen ions to the opposite side of the equation. Number four, add up the charges on each side and make them equal by adding electrons on the more positive side so that charges on left hand side and right hand side they become equal. Number five, electrons on each half equation must be equal. If they are not, then multiply an equation with a certain integer so that electrons can be cancelled out in both the equation. Then half equations are added together, cancelling out the electrons, and whatever common constituents are there, they should also be cancelled out. So this is in brief the half equation method to balance a redox equation. But what next? Can we obtain a complete balanced equation from a balanced redox equation? Probably no. We require more work to further balance the complete equation. Let us see how we can do this. So I am taking an example of permanganate titration of ferrous sulfate with KMnO4. This titration is being carried out in acidic medium, and this is a very common experiment in laboratory. So this is the balanced equation. Ferrous sulfate is reacted with potassium permanganate in acidic medium to give ferric sulfate, manganese sulfate, potassium sulfate, and water. And this is our balanced redox equation. So let us do a small exercise. First, how to balance a redox equation, right? Then we shall proceed further. So step first, write a skeletal equation. A skeletal equation is nothing but an unbalanced equation, nevertheless featuring all the reactants and products. So this is our skeletal equation. Ferrous sulfate is reacted with KMnO4 in presence of dilute sulfuric acid to give ferric sulfate, magnesium sulfate, potassium sulfate, and water. Then second step is write down the redox equation. So we have written the redox equation. Ferrous ion is converted into ferric ion and permanganate ion is converted into manganese ion. Right? Next. Then step 3, write down the reduction half equation. So this is our half equation. Permanganate ion is reduced to manganese ion. So let us balance it by our well-known method. As we have already discussed, oxygen shall be balanced as water. So here we have 4 oxygen atoms. We have added 4 molecules of water to compensate. Now we have 8 hydrogen atoms. So we have added 8 hydrogen ion. Here we have 7 positive charges, 8 minus 1. Here we have 2 positive charges. So we have added 5 electrons to the left hand side of the equation. Now our reduction half equation is balanced. Since electrons are being added, therefore this is a reduction reaction. Clear? Step 4, oxidation half equation. So this is straightforward. Ferrous ion is being oxidized to ferric ion. So let us balance it. We have added 1 electron to right hand side of the equation to make the charges equal. Then we have multiplied it by 5, since in equation first we have 5 electrons here. So we are going to cancel these electrons. Therefore we have multiplied it by 5. Then we shall add these two equations to get a balanced redox equation. Clear? Now, from this point onward, our real work starts. Now I am going to tell you the certain steps from which, or with the help of those steps, we can write down a complete neutral balanced equation. This is our topic, right? So the first step is write full equation with counter ions by taking same coefficient as we have obtained in the balanced redox equation. Coefficient means these are the coefficient 5, 8, 5, 1, 4. These are the coefficients. So we have written 5 molecules of ferrous sulfate plus KMnO4 plus 8 H2SO4 or the sulfuric acid, then 5 ferric sulfate, magnesium sulfate, potassium sulfate, and water. Anybody can guess that this is not a balanced equation. So let us proceed further. This is our equation which we have obtained from balanced redox equation, and we can see that this is not a balanced equation. Why? Let us check. Here we have 5 atoms of iron, but here we have 10 atoms of iron. Similarly, we have 2 potassium atoms, whereas on left hand side we have 1 potassium atom. If we count the sulfate ion, here we have 5 plus 8, 13, and here we have 15 plus 1 plus 1, 17 sulfate atoms. So this equation is not balanced. So let us see what to do further. Make it a table. For your convenience, I am giving this table. However, you should do this calculation verbally or in your mind. So make a table and tabulate the number of all the atoms in left hand side as well as right hand side, right? So we can see here we have 13 sulfate ions, whereas on right hand side we have 17. Likewise potassium 2, here we have potassium 1 atom, manganese 1, iron 5, and here we have 10 atoms of iron. Next step is important. Balance oxidant and reductant first. Whatever we have taken in our redox equation, we should balance those oxidant and reductant first. This is very important. So here we have 5 atoms. So to make it 10, I am going to multiply it by 2. Only this ferrous sulfate, not the whole equation, not the whole left hand side equation. only this. So I have made this 10, right? Now I can see that here we have 10 iron atoms, and on right hand side we also have 10 iron atoms, right? Then come to potassium permanganate. So you can see on right hand side we have 2 potassium atoms, whereas on left hand side we have 1 potassium atom. So I am going to multiply it by 2. Now my potassium atoms, they are balanced. In order to balance manganese atom, I shall put 2 here. Now up to this, my 3 atoms, they are balanced. Number 1 is the iron, number 2 potassium, and number 3 manganese. So let us proceed to next step. Next step is balance other counter ions. If we count sulfate ion, so here we have 10 and 18, and on right hand side now we have 15 plus 2, 17 plus 1. So incidentally, the sulfate ions, they are balanced. But you will find many situations, many examples where other counter ions, they are not balanced. And you will have to put some extra efforts, some extra strategies to balance them out. Right? But this is the next step. Now, last step is balance hydrogen and oxygen as water molecule. So we can see here, we have iron, manganese, potassium, they are balanced. Now we have 8 oxygen atoms here and 4 oxygen atoms here. Likewise, we have 16 hydrogen atoms here, and here we have 8 hydrogen atoms. So as per the rule, we shall balance oxygen and hydrogen as water molecule. So how many are deficient? We have 4 water molecules, they are deficient. So I am going to add 4 water molecules, right? You can see that our whole equation is balanced now. You can count 10 iron here, 10 here, then 2 potassium atom here, 2 potassium atom here, then 16 hydrogen atoms on left hand side. Here we have 16 hydrogen atoms on right hand side. Sulfate ions, 18 sulfate ions on left hand side and 18 sulfate ions on right hand side. So this is the procedure. Now let us summarize our procedure. Number 1 is the right skeletal equation. Number 2, right redox equation. Number 3, balance redox equation by half equation method. Number 4, write full equation with counter ions by taking same coefficient as in balance redox equation. Number 5, tabulate atoms in left hand side and right hand side of equation. Step 6, balance oxidant and reductant first. As I have already told you, this is very important step and you should stick to your exercises on this step. Then number 7, balance other counter ions. Number 8, balance hydrogen and oxygen as water molecule in the last. This is also important. Now I am going to give you an assignment. This is another example of permanganate titration of Mohr salt. Mohr salt is nothing but double salt. It's ferrous ammonium sulfate, and it's a common laboratory experiment in class 11th standard. It is being titrated with the KMnO4 solution, where the KMnO4 solution is the self-indicating, and at the end point we obtain a pink, light pink color. So try your hand on this equation and see if you are able to write down a completely balanced equation by the help of the rules which I have told you. And do write to me on the comment lines. Okay?